on semiconductors, drones, rare earths, and critical minerals related to the supply chain resilience issues, economic security, national security, and technological politics. It is a pleasure to welcome all of you to the launch event of our new research report, 4 ounces deflecting 1,000 pounds, analyzing Chinese elites' perspectives on winning the U.S. China AI competition. The phrase 4 ounces deflecting 1,000 pounds, drawn from Chinese martial arts Tai Chi, captures a strategy of using limited resources to stronger force. So interestingly, it has become a common way for Chinese AI leaders like how they approach competition with the U.S. and its allies. So these reports take a different angle. Instead of asking whether China is catching up, we actually ask, how do Chinese AI elites themselves see the competition? We've been using open source analysis of their own words. We find a nuanced picture, clear recognition of weaknesses, especially in advanced compute, alongside a strategy to work around constraints by leveraging their scale, efficiency, and ecosystem advantages. So this is a very great honor that we can have this chance to introduce this report. We're going to have 2 of our co-authors, Nathaniel Chen and Emery Wang, in charge of presenting these research findings. And also, we're very honored and distinguished, and we are very honored to have 2 of our discussants from SSP, David Lin, and Merrick's Wendy Chang. So before getting started, I have to briefly introduce today's 4 of our panelists. So from the authors part, I'm introducing Nathaniel Chen. So Nathaniel is a policy analyst with the Economic Security Research Program at Dset. His research is focusing on critical and emerging technologies, including semiconductors and advanced robotics, with expertise in export control, trade policy, resilient supply chains, and economic statecraft. Before joining Dset, Nathaniel worked at the U.S. Department of Commerce, International Trade Administration, advancing U.S. trade policy related to emerging technology standards and intellectual property. The second co-author and who are presenting our research findings jointly with Nathaniel is Emery Cai Wan. Emery is a non-resident fellow at Dset, currently based in Tokyo, Japan, specializing in Chinese local government technology and industrial policy. Emery's works at Dset's Economic Security Program examines patterns of collaboration and frictions among major Chinese technology firms, local governments, and the central authorities. Emery holds a bachelor's degree of business administration from National Tianjin University, Taiwan, and she's currently pursuing a Master of Public Policy at Japan's National Graduate Institute for Policy Studies. Then I'm introducing 2 of our distinguished discussants. David. So David Lin is the Senior Director for Future Technology Platforms at the Special Competitive Studies Project at CSP. Prior to joining SSP, David served for 12 years at the U.S. Department of State and the Central Intelligence Agency, focusing on China and technology policy. His expertise includes Chinese industrial strategy, data, and cybersecurity policies, and digital infrastructure development as well. David holds a master's degree in security policy studies and a bachelor's degree in international affairs from the George Washington University. So last discussant join us is Wendy Chang. So Wendy is the senior analyst at the MacArthur Institute for China Studies, known as MERICS. She researches how developments in AI, self-driving cars, metaverse, quantum, and more can transfer from China's digital economy. As a Taiwanese American, Wendy also watches cross-strait relations closely. Prior to joining Merix, Wendy worked as a senior software engineer at companies Berlin and San Francisco. Wendy holds a Master of Engineering in Computer Science from MIT. So before getting started to present our research, because this is a great chance and great privilege to have all of us sitting together for discussing these findings. So I'm first to having all of our discussants and panelists to take a snapshot. So yeah, my staff is going to in charge of capturing this scene. All set? So we're releasing this snapshot later in our social media and releasing in our newsletter. Okay. So
Zhishan, please share the screen so we can see all of the participants, all of the commentators. Yeah, thank you. Give me a second. Okay, 1, 2, 3. One more, sorry, one more. 1, 2, 3. Oh, shit. Okay, now please share the screen right now. Thank you.
That's it. Okay. All right, to walk us through these research findings and insights, firstly, I'm delighted to introduce our co-authors, Nathaniel Chen and Emery Wong, to present our research findings. Nathaniel and Emery, the floor is yours.
Great, thank you very much, Jeremy. It's an honor to be able to present our findings, as well as to be here with a very distinguished panelists. So I'll just dive right into it. So a big impetus for our report was this January's AGI Next Summit in Beijing. So for those of you who don't know, this summit was hosted by Tsinghua University and Zhipu AI. It's held in the Zhongguancun Innovation Center, which is right next to Beijing University and a short drive from Tsinghua University. And that area, specifically the Wudao subway stop, is known as the center of the universe because it's right next to many leading Chinese technology companies, including AI companies such as Zhipu and Moonshot. And so in many ways, this event in January is held at the beating heart of China's AI industry. Tsinghua has created some of the leading names in AI, and there are a host of young AI entrepreneurs who are Tsinghua alum, including, for example, Yang Zhilin, the founder of Moonshot. Tang Jie, the co-founder of Zhipu, was a professor and vice dean of the computer science department at Tsinghua, and he is a speaker at the most hyped event of this summit, which is a roundtable, which includes the so-called 4 kings of open models. So Tang Jie, Lin Junyang from Alibaba, Yang Zhilin from Moonshot, and Yao Shunyu from Tencent. And the roundtable's closing remarks are delivered by none other than the Tsinghua professor Zhang Bo, who launched Tsinghua's first class on artificial intelligence in 1979. And so there are a lot of headlines that come from this event. Some stories focused on Lin Junyang, at the time the lead of Alibaba's Chen Wen model, saying there's only a 20% chance that a Chinese firm will be the leading AI company in 3 to 5 years. Others focus on the fact that the speakers saw Palantir, the US company Palantir, as a model for Chinese companies. But regardless, this was a gathering of half of China's AI community, as some people put it, and arguably some of the most important people in Chinese AI. So what we wanted to do with our report was to understand more how Chinese AI elites think about China's position in AI and competition with the United States. And so we wanted to look at particularly how leaders like Tang Jie, like Lin Junyang, like Yao Shunyu are looking and thinking about these issues. Next slide, please. So a way China's strategy is often characterized in these circles is the phrase 四两拨千斤, or roughly translated 4 ounces deflecting 1,000 pounds. As Jeremy mentioned, it's a Chinese idiom originating in Tai Chi philosophy, which refers to the use of a smaller amount of force to deflect, meet, or dissolve a larger force. And so, for example, when DeepSeek stunned the world with the release of its R1 model, it was described as 四两拨千斤, right, using 4 ounces to deflect 1,000 pounds. That DeepSeek was able to create this model without the use of advanced NVIDIA chips. And so for this report, we look specifically at how Chinese AI elites view this 4-ounce strategy in Chinese, and specifically China's response to the AI stack to the weight of U.S. export controls on advanced chips. Next slide. And so you can kind of see that here in this graphic. So Jensen Huang famously described the AI stack as a 5-layer cake. We look at 6 layers, so market applications, models, compute, infrastructure, talent, and financing. And as you can see from this chart, the main focus of U.S. restrictions, starting from the October 7th export controls, has been on Chinese compute. And Chinese actors continue to acknowledge the impact of these controls on their compute and AI industry. And the other layers of the AI stack have had to accommodate and compensate for this limitation. And so we'll dive into each of these layers, and I'll cover quickly market applications and models, and then turn it over to my colleague Emery to cover the rest. Next slide. So market applications. So the key takeaway here that we found is that Chinese elites feel that China's strength in so-called practical diffusion of AI is concentrated particularly in consumer and industrial applications. But enterprise AI is a key area where China faces challenges compared to the US. So if for consumer AI, China's success is predicated on the same logic as in other high-tech industries, just like China's internet apps like ByteDance's TikTok, just like food delivery services, EVs, and other industries, you see brutal competition, state subsidies, mega price war consolidation, and rapid iteration that will forge these champions in consumer AI. And so we've already gone, and we've already seen this, the war of 100 models to the 6 AI tigers of Zhipu, Moonshot, Minimax, Baichuan, StepFun, and 01 AI. And now Zhipu and Minimax have completed their IPOs at the beginning of this year. And Chinese elites, including recently the founder of 01 AI, in an interview with the Financial Times, said recently, where he said that Chinese firms are going to be a greater source of app innovation than their American peers. And another reason for that is because Chinese consumer applications increasingly do not need frontier capabilities. And more important is the kind of user experience and interface. For example, ByteDance's Doubao model is not a frontier model, but leads in App Store downloads in China. In contrast, enterprise AI is a challenge. So at the AGI Next Summit, this was something that was mentioned repeatedly. Companies are less willing to pay for software in China, and there is not the same mature software as a service market as in the US, which is why many Chinese firms say that they look to Anthropic or Palantir as a model for this SaaS model of AI. And it's why DeepSeek and Zhipu, for example, are selling these all-in-one machines called ETG, which is a hardware and software package, precisely because Chinese firms don't want to pay for software. But again, this is very distinct from industrial applications of AI, as you see in the bottom, which China sees itself as having a strength. And so this is kind of not just generative AI and models, but also kind of machine learning and computer vision that are being readily deployed across different industries. And you don't need frontier models in many cases. You can use smaller models that are fine-tuned for specific usage, and that can be good enough. Next slide, please. And physical AI is the next big thing, and like a big part of that is China has the world's #1 manufacturing output, and that means they have a lot of data that goes into that. And so you can see the increasing application across the different industries, from steel manufacturing to agriculture to healthcare. For example, Alibaba's Damo Academy's Panda system, designed to detect pancreatic cancer from low-dose CT scans, has already diagnosed dozens of cases of pancreatic cancer and it's received the U.S. FDA Breakthrough Device designation in 2025. Next slide. So for models, that's the next layer. And this is supposed to be kind of the most representative manifestation of this 四两拨千斤strategy, 4-ounce strategy at play. So without access to advanced NVIDIA chips, China's firms are pursuing open models to reduce trial and error and quickly get developer feedback. DeepSeek has pioneered its natively trainable sparse attention mechanism to reduce training and inference costs. And now everyone is kind of using some kind of this mixture of experts architecture to use fewer resources to train powerful models. And it seems to be working. You kind of see the numbers on the slide. China is leading open model downloads on Hugging Face. Countries like Japan and Singapore and even Silicon Valley startups are embracing open models. And the China Academy of Information and Communications Technology recently put out a report saying that in terms of algorithm architecture, these sparse attention mechanisms represented by DeepSeek's NSA or Moonshot's mixture of block attention have become an important technical path to improve model efficiency. And so the question is, why at this AGI Next Summit did Zhipu's Tang Jie say that, despite the embrace of open models, there will still be a gap and that there are still challenges and gaps for China. And so one potential reason is that, founders and business leaders still feel that China should pursue both open and proprietary models. So Robin Li at Baidu or Yang Zhilin at Moonshot have said that companies with proprietary business models attract more funding and talent and are more viable long-term. Next slide. And the second point is something that our Dset colleague and the democratic governance team has looked into, and it's that DeepSeek and Minimax have documented relied on these distillation attacks on U.S. models to train. So you do have these cutting costs and increasing efficiency, but they in many ways have still relied on these distillation attacks on OpenAI and Anthropic. Go into more detail on that later. So I'll stop there for now and turn the floor over to Cai to talk about compute.
Yeah, thank you, Nathaniel. So I will start with the high-end training compute part. First, we identify the lack of high-end training compute to be the most critical bottleneck for Chinese AI development. According to Chinese AI elites like Tenchin's Yao Shunyu, this bottleneck is resulting from two critical barriers. First is the chip production capability and capacity, and the second is the software ecosystem. In hardware, domestic foundries' mixed capacity is mostly reserved for Huawei, limiting capacity for smaller chip design firms like Byron and Moorthreads. In software, Wei Shaojun, vice chairman of the China Semiconductor Industry Association, has warned that the high reliance on CUDA implies that China's AI development is eventually linked to NVIDIA and the US, as the figure 2 shows. Next slide, please. To overcome this bottleneck, in hardware, China has adopted a strategy of quantity for quality. For example, Huawei has tried stacking large numbers of chips together to achieve a necessary computing power. Making progress in its previous cloud matrix 384, Huawei will begin to sell Atlas 950 SuperPod, which contains 8,192 ASINT 950 DT chips in this year's Q4. In software, Huawei, Moorthreads, and other Chinese firms are seeking to develop alternatives to NVIDIA's CUDA architecture. Huawei made its CAN an open source architecture, expecting this decision would allow troubleshooting and attract more users. However, by far, it is still difficult for Chinese firms to replicate NVIDIA's performance. For example, it is reported that DeepSeek's use of Huawei chips caused delays in its release of its newest model last August. However, I think we will soon see the result of this attempt at the end of this month when DeepSeek will launch its V4 model. Also, although iFlyTech and Zhipu claim to train their model on Huawei chips, many other Chinese firms like Alibaba, Minimax, and ByteDance continue to use NVIDIA chips despite export controls. In software, the gap between the number of developers remains and will not be easily closed. In 2025, while Huawei announced that CAN accumulated 6,000 deep contributors, CUDA already had over 4.5 million developers. So to conclude, reliance on US technology in high-end training compute is the most thorny issue that China recently faces. Next slide, please. So if compute is China's most acute disadvantage, observers often point to energy and infrastructure as a Chinese advantage. In energy, China generates more than twice the electricity of the US and delivers through the world's most extensive ultra-high voltage transmission network. This could allow China to realize the energy consuming strategy of quantity for quality, which we previously mentioned. In compute infrastructure, China has built the well-known National East Data West Compute Initiative. And to complement, the Ministry of Industry and Information Technology has also established the National Computing Power Internet Service Platform, which centrally coordinates compute resources nationwide. However, we find that Chinese cloud industry leaders have challenges in how to efficiently channel energy to data centers. Moreover, data centers originally built for training sometimes lack the hardware optimization required for more inference loads, leaving the data centers unused. But however, if China can overcome these challenges, abundant energy and comprehensive infrastructure will become its biggest strength in the AI competition. Next slide, please. In general, Chinese AI talent leads in quantity, but the lack of innovation culture remains a long-term issue to them. In number, China produces approximately 1.4 million STEM graduates every year, which is more than 6 times the US output. In addition, the government also actively provides platforms for collaborations between enterprises and universities, like the Beijing Academy of Artificial Intelligence. However, Chinese AI elites point out that the key of AI progress lies in culture rather than in number. For example, Tenshin's Yao Shenyu argues that what China may still lack is enough people willing to break new paradigms or take very risky bets. To address this issue, the government encourages AI labs to focus on long-term innovation by reforming evaluation systems and supporting high-risk long-term research through national funds. Okay, next slide, please. So when talking about national funds, in finance, Chinese AI financing faces challenges in scale and field. In the scale of investment, US private sector funding of AI of 109 billion in 2024 dropped China's 9.3 billion by a factor of 12. Moreover, the Chinese government worries that the private sector prefers established and profitable AI firms, overlooking early-stage strategic research. In response, the government has adopted a strategy of using small government capital as 4 ounces to attract private investment as 1,000 pounds. Governmental capital will serve as the signal to private investors, encouraging them to invest in selected strategic firms. Next slide, please. In this report, we also provide observations on the role of private capital and the diverse funding models of Chinese AI firms. First, Chinese private VCs actively help the AI industry building ecosystem, stressing that without an ecosystem, even the best chips are just expensive sand. And our second observation is that Chinese AI firms have diverse funding models. On one hand, chip design IPO, including MetaX and Morthreads, often attract significant private capital. But besides private capital, firms like Zhipu maintains close ties with both Beijing municipal and central government authority, assisting China's military AI research. On the other hand, DeepSeek is fully funded by its parent company, Highflyer Quant, a private hedge fund, and does not accept any external investment. This allows the company to avoid short-term profitability pressures and focus exclusively on foundational model development and its goal of achieving AGI. To conclude, the dynamic between government and the private sector is worth noting. Yeah, thank you.
Thank you. So to summarize, I'll just walk through the policy implications very quickly. As you can see, China's 4-ounce strategy plays out differently depending on the layer of the AI stack that we're talking about. And in some ways, the 4-ounce strategy applies more in some cases than in others. And in response to the structural, geopolitical, and resource limitations coming in many ways from U.S. restrictions, China has resorted to many different tactics and strategies to overcome those weaknesses, from nimble innovation under constraints to brute force to even sheer scale. And China's approaches are often neither elegant nor resource efficient. And in each of these efforts, we kind of have seen that many elites acknowledge the challenges that they face. Next slide. And this is kind of another view of how we depict the information of the different layers, and this is all available in our report. Next slide. And so I won't go into tremendous detail, and I'm happy to dive more into this in the Q&A, but I just wanted to highlight one thing, which is one of the things that we highlight in our paper is that, and we're not the only ones that say this, but an export control and kind of AI leadership strategy that's focused solely on advanced training compute hardware is insufficient. It's done a lot to constrain China's capabilities, but ultimately, China is trying its best to overcome these restrictions in many other arenas. And so from our vantage point, the United States should take action where appropriate to counter China's advances in these areas. And so some preliminary ideas that we propose include, for example, increasing the scope of the U.S. persons rule to restrict U.S. persons from contributing to China's sensitive AI capabilities, or under models, kind of restricting the use of Chinese models in the U.S. But these are ideas to spark further discussion. But I'll stop there and look forward to the Q&A. Thanks.
Well, thanks so much for Nathaniel and Emery to present our research findings. To remind our participants today, so in the last 30 minutes, we're going to have a Q&A session. So we'll allow you to type in to send your questions first, and then I can have our panelists to respond to your question. So if you see the bottom right side, there's an icon of like meeting tools, and you can click the meeting tools and you open that, and there's a Q&A button. So open the Q&A button, you can type in the questions. But when typing questions, please, if possible, identify yourself. And then we can. So I'm going to be in charge of reading your questions and for our presenters and panelists. Okay, so I'm going to the next part, which is the commentary from our discussant. First, I'm going to invite Wendy to come in. Wendy, you got 10 minutes, so the floor is yours. Thank you.
Thank you. Hi, everybody. It's an honor to be invited to participate in this report launch. Very happy to be here. I work at Merix. We cover a lot of the same topics. In fact, last year, my team wrote a report on also the AI stack, although focusing more on the tech stack. So I really enjoyed reading this report. I think it's great. So congrats to the team. I think the title is really wonderful. This idea of 4 ounces deflecting 1,000 pounds really nicely captures what China is doing. So I think it's very aligned with my own continued observation of what China is doing, which is it's not fighting the U.S. head-on, right, when it comes to the AI race. Rather, it's taking its own strengths. It's taking stock of its own strengths and its own weaknesses and kind of forging its own path. I would say China's developing a distinct path. It's quite different from the Silicon Valley model, which we see with a lot of concentrated large amounts of capital, developing cutting-edge solutions and then deploying those solutions, first of all, to a corporate environment. So I think Nathaniel pointed that out. In the US, there's a much stronger ecosystem for enterprise software, right? It really pioneered that model. So that's the primary target audience for AI solutions. Whereas in China, we really see open source, which I think is a very key, at least for me, a very key focus for this report, for me, a high point of interest, because I think the open source arena is a very interesting one. And I think it's rather interesting how the US companies for now seem to be kind of neglecting this arena. So from looking at leaderboards of large language models, we see that in the beginning, the leading open source models were Meta's Llama and these other Western models. But by now, the top 10 absolutely dominated by Chinese models. And I think that's both due to Chinese companies' strategy to focus on this area. And I think in the report, you guys really point this out, that it's a cost war, right? Chinese models are so much cheaper. They're so abundant. They're so easy to assess through these open source models, open source platforms, that then they really attract wide adoption, either in the global South or by the research community, which I've heard is the case because of largely of cost concerns. And I think that's a really interesting dynamic to point out. Another really interesting dynamic from the report that I liked is this consumer AI focus of the Chinese market. So rather than building really large, really expensive, really cutting edge models, it's more about taking existing models and deploying them through developing a lot of consumer apps. So there's this focus on developing applications based on what you already have. And we see that, I think, starting from day one in China, you see this focus on, okay, what can we build with this that would be sticky for the average person, especially with consumer apps, right? And I think I wanted to say that I think your example with Doubao, very interesting one. And I think in general, based on what I'm reading and based on what I have access to myself, I think outside of a Mandarin-speaking environment, outside of China, this kind of coverage is really lacking. So I think maybe a tip for all of us, this could be an interesting space to look more into, because the Chinese ecosystem of consumer apps is pretty closed, right? Because they're pretty separate from, they're not using US products and vice versa. So we don't really know what's going on in there. And I think looking at Doubao or looking at older generation of big tech, of BAT, for example, they have these very comprehensive, very sticky products with a huge audience. And how that ecosystem works, I think, is very interesting. And of course, recently there's the OpenClaw example, which also came up in the report. So you have this open source tool, which really takes some amount of technical know-how to operate with, right? But then inside China, you saw this very quickly developing hype and super high adoption numbers from people. And this kind of course, it's aided in part by big tech responding super quickly, right? By big tech already rolling out solutions, rolling out plugins, even offering promotions to help people install it and so on. I think that's part of it. So the ecosystem reacts very quickly. And the Shenzhen government even came out with policy that said we're going to support businesses, new businesses that start to use OpenClaw. So that's one part of it. But I think another interesting thing is also the Chinese consumer base is somewhat more optimistic, maybe. So I think that's another thing that's worth thinking about. Another point in the report, I think, on industrial AI, that's also, I think, really worth paying attention to. It's a big strength of the Chinese ecosystem. And I agree with that a lot. So there's a lot of different sectors. They have been primed to adopt technology. There's been sustained policy support from China before generative AI. It's always been kind of in the policy to adopt technology, to elevate different sectors to make them better and more competitive. And I think in the AI Plus initiative, this really comes through. And so I really agree with that, what you said in the report about that. And tying that to also physical AI, I think you also made that connection in the report. So between industrial AI and also the next step being physical AI, I think China is really shaping up to compete in that arena, right? So taking what they're good at, which is manufacturing different parts and different components, and combining that with AI. Now, my big question for that, of course, is, okay, so for now, it kind of looks like the robotic AI stack is a lot like the AI stack we look at here, where except, there's a reversal because the hardware, they have the hardware. But when it comes to the software stack for robotics, again, it looks really NVIDIA dominated. So the software ecosystem is very NVIDIA based, and the the hardware chips. So the robotic brain, the hardware, again, like you see the leading robotic startups really all using NVIDIA chips. So where does that lead us? So I think to kind of close out, I will say the $1 million question, or the billion or $1 trillion question for me is, of course, at the end of the day, where does this 4-ounce strategy lead? Which approach will prevail? What is the kind of winning roadmap for China? So I think that's maybe something we can all think about. It's okay, so how far can this open source, cheap, low-cost solution diffusion strategy go, right? Is there something the US can do to turn back the tide? So say if there's some way for us to incentivize OpenAI or Anthropic to pay a little attention to the open source market, does that then immediately revert back China's advantages, or does it not? How does it go? So I look forward to tracking these developments along with you guys in the upcoming months and years. Thanks.
Well, thanks so much, Wendy. I love your lots of the comments. It helps us a lot. I just recall me that when we were doing this research, every day we are very overwhelmed for loads of a bunch of information, but also because as you mentioned, the Chinese ecosystem is so isolated from rest of the world, right? In the English context, if you're not a Mandarin speaker, even not using Mandarin as your working or living language, and if you're not going to access to this Chinese service as AIs, but more and more AI is like being used in their models being used by the US and the rest of the world. But for other parts of the application, then we still have to figure out as a Mandarin speaker, I think we can keeping contribute this research from a Mandarin speaker's position and then keeping contribute to our policymakers in the allied countries. But I love your team's research findings. So really recommend our audiences, especially from Taiwan, to access to Merrick's website and click and read Wendy and Tim's research finding. And then the next discussant is David. So David, I'm a big fan of David because I always reading David's report and then also watching live stream of David's testimony in the U.S. Congress. And also we always learn a lot from you. So it's very privileged that we can have you to comment on our reports. So the next 10 minutes, David, the floor is yours. Thank you.
Thanks, Jeremy. And again, congratulations to the Dset team, to Nathaniel and Tai. I think it's a really, meticulous researched product, and lots of detailed quotations and anecdotes in there that, like I told you guys in the pre-show, I think I'll be pulling for my own research also. And I think it does a world, Wendy kind of made reference to this too. I think it does definitely help illuminate more light on the Chinese AI ecosystem, in the sense that, in the popular discourse these days, China is described as a monolith, and this really parses through just the wide menagerie of stakeholders, companies, government officials, investment vehicles, all these different stakeholders that comprise of the Chinese AI ecosystem to paint a much more complicated picture than it is than just, Beijing telling the industry to do X, Y, and Z, but instead it's this very chaotic, mix of stakeholders that are all competing for market share, have different interests that sometimes align with Beijing's interests, but sometimes don't align with Beijing's interests. And I think this report really puts a spotlight on some of those actors. So again, kudos and congratulations on getting this out. Maybe just a handful of bullets that I wanted to comment on that really jumped out at me reading through the report. And one of those is, I think, speaking to that point of all the disparate actors involved in the Chinese AI ecosystem, is, Beijing is now pushing its anti-involution efforts, which is trying to encourage companies to not, stab each other in the back all the time, at least, but try to, compete more progressively so that they're actually moving the technology ball forward and not just undercutting each other all the time. And I think this report, again, highlights how some of these companies are working collaboratively, but also working competitively as they should as commercial companies. And I do really like how Nathaniel, Tai, you guys broke down the AI stack by consumer, enterprise, and industrial AI. I thought those three categories were really illustrative, again, of how complex the ecosystem really is. And I don't think I've seen that anywhere else in the China analysis either. So I thought that was really interesting. Applying this involution theory, though, I start to wonder whether or not U.S. AI companies are prepared to confront Chinese AI companies, involutionary approach to AI competition. I think we're seeing reports in the U.S. now of, distillation attacks against U.S. AI models. Of course, there's chip smuggling going on in China to allow access to banned chips. And there were reports a couple weeks or months ago about how DeepSeek V4 was being previewed to Chinese chip makers for optimization before being released to foreign chip developers to kind of give domestic companies in China that, that lead time, that leg up to optimize before they enter the global marketplace. And I think that speaks to this involution spirit inside of China, which is that Beijing will use every ounce of means at its disposal to compete, be it through, distillation attacks, cyber attacks, through chip smuggling, but also through overt legal commercial means to compete. I think that's maybe a competitor that U.S. AI firms aren't ready to compete with just quite yet. So that's one point. I think, the authors made a great point pointing out how NVIDIA's CUDA ecosystem is a huge moat. So much of the emphasis has been put on, leading AI edge chips, and less emphasis, I think, in the popular discourse at least, has been put on just the developer ecosystem and how the US and how NVIDIA is still so dominant in that space, and how China has struggled for decades now building a similar open source developer ecosystem in China because they are already so embedded in the US developer ecosystem. So I think that's a really important point that the report highlighted as a key moat for NVIDIA, but also for the US. Two interesting stories that I think are still currently developing. So you all address and passing in the report, but I'm wondering, and maybe we can save this for the discussion, how this will, or what your take on how this will play out for the future of the US-China AI competition. One is we're getting more and more reports now that DeepSeek V4 was trained exclusively on Huawei chips and optimized on Huawei chips. And initially that was why there were delays for V4's release because there were some technical complications. Again, maybe for later in the discussion, I'm curious what your thoughts are and what this implies for the future release of Chinese models, open and proprietary weight models. The other new development too, which I don't think I saw mentioned, was the exit bans that were imposed on the founders of Manus AI, and how that may have a chilling effect on the startup ecosystem inside of China. Of course, I think, again, in the US, I think the two Chinese AI firms that have penetrated most deeply into American discourse are DeepSeek, of course, but also Manus AI, because they were acquired at this eye-watering amount of $2 billion by Meta. But then subsequently, the founders were exit banned when they were summoned by Chinese regulators and went back to mainland China. And Beijing is obviously signaling here that they're displeased with how Manus essentially, Singapore washed themselves and from the beginning really kind of oriented themselves for the overseas market and positioned themselves to be sold and ultimately acquired by a foreign firm. By imposing these exit bans, Beijing signaling its displeasure here. And I wonder what implications or repercussions that will have for the rest of the AI ecosystem. And maybe just my last point here, you do make mention to how in the 15th five-year plan, Beijing puts a strong emphasis on the need to invest in R&D, basic R&D and fundamental research, and how that may be one of the ounces of the 4 ounces of how China will ultimately try to deflect some of the pressures that it's being put on by the US. I think this is a really important point that we here in the US maybe even underappreciate. Just a couple weeks ago, just last week, I think, the OECD released new statistics that said that in 2024 at least, China for the first time exceeded US on gross R&D spending at like $1.03 trillion versus the US's $1.01 trillion, which is a sad state of affairs, frankly, for the US R&D ecosystem, and something that the US has traditionally prided itself on being in the lead in basic and fundamental research. And that's something that I think we do in the US at least risk losing that lead if we don't pay closer attention to this. So all to say, great report. It also leaves me wondering too, and I don't know to what extent this is actually in Dset's broader remit, but you make great recommendations on what the US should do. I'm also curious what you think on what Taiwan's role in all of this is, what the role that, Taiwan's obviously, booming chip sector, but also nascent but emerging AI sector has to play in this broader US-China tech competition. So I'll leave that there for you. And again, just great job, and had a great time reading your report, and I think it'll be incredibly resourceful going forward.
Well, thanks so much, David, for commenting our research. There are many approaches and many dimensions that you mentioned. I feel it's very helpful for us to conduct a further research in the future. But currently, the points that you identify, I believe that's a very critical issues from our side. We are simultaneously doing another projects focusing on some of the stack you mentioned. Because we are kind of controlling time very correctly, so in the next 10 minutes, maybe we have each of our co-authors to respond if you want. 5 minutes for Wendy and David's comment. Nathaniel, if you want to raise your hand, maybe I can give you the first 5 minutes, and then Emery, you can spend the last 5 minutes as well.
Sure, thank you. I won't take 5 minutes, but I very much appreciate Wendy and David, your detailed feedback and very helpful contributions. I think it's maybe just a couple points. The question on where does this 4-ounce strategy lead is very interesting to me, because, and because I think there are a lot. It's very hard to know, right? And there are a lot of kind of theories out there, and one I remember reading, there was an analysis by the Chatham House that kind of said, if there's an AI bubble, and the bubble bursts in the U.S., the U.S. will end up kind of ceding this vast consumer market to China, and the U.S. will remain dominant in kind of national security and like paid enterprise applications. And so that was, I thought, a very interesting take. I don't know if that will actually play out, but I think in terms of thinking through how this foreign strategy will lead, one thing in terms of the agents that I think is really interesting is that kind of the way a lot of these companies lay it out is, this year is kind of the year of AI agents, and then AI agents is kind of the stepping stone to physical AI, and enabling autonomous robots, enabling smart cities and that kind of thing to happen. And so it'll be very interesting to see how this open cloud trend plays out. And it feels like we're seeing in real time Chinese policymakers think through how to deal with this, because on the one hand, this can be a really big kind of revenue generator, monetization, really revolutionary. But on the other hand, there are all these security risks, data risks, potential of kind of getting out of control, that not just China, but the U.S. and other countries will have to kind of grapple with from a regulatory and governance perspective. So that'll all be very interesting to think through. But I think I'll stop there and turn it over to Tsai.
Okay, thank you, Wendy and David. So I would like to respond to David's comments, especially on the collapse between different stakeholders in China, and also about NVIDIA's CUDA as a moat. So first, I would like to talk about NVIDIA's CUDA and Huawei is trying to compete with CUDA with its CAN system. So I think about this question that whether can eventually build its own ecosystem and even exceed CUDA in the future, because China has been so stressing on open source, and it seems like open source is like magical that every problem can be solved by that. But my personal view is that even though we say that can maybe attract many global South users, and then they can gradually build its ecosystem, but I think the major point is that we all know that there are great progress and potential in the global South, but I think we would all agree that most of the exciting development will still happen in maybe the US or the East Asia, global North in maybe the next decade. So that is why my conclusion is that I don't think the gap between the users of CUDA and CAN would close up that soon. Yeah, so this is why in this report, we still recognize CUDA as a moat. And another point that I'm very interested in is that talking about the Chinese firms sometimes are aligned to Beijing's policy and their political goal, but sometimes they are not. And this is especially demonstrated in the past, including the semiconductor policy, because my research may focusing on the semiconductor development of China. So I think it's not only in AI, but also in semiconductor projects in the past, and also in the data center buildings, we can also see a similar phenomenon that even though the central government may try very hard to spread subsidies and national funds to promote the industry, but there are still significant ways. And this is why I think sometimes when they are saying 4 ounces, they are actually paying a lot of efforts in this policy. Yeah, and for example, in the data centers building part, we see many information about they were complaining that even though because of the local governments, they want to earn more subsidy from the central government, so they will just give out a lot of subsidies and build a lot of data centers, and many of them would become unused because they just not match the demand for the newest training demand. Yeah, so this is actually quite similar to the semiconductor projects in the past 10 years. So a question that I've been thinking about is that, is the foreign strategy a new strategy responding to US restrictions and progress in AI? Or is actually like a consistent strategy that China has been always using to promote its technology development, including in semiconductor and also in like green energy or any other technology policy? So I think this is a question that is worth researching, because like if we have a more comprehensive knowledge in China's technology development policy, then maybe we can see more clearly which this foreign strategy would go. Or maybe it would just eventually like giving out a lot of subsidies and some of making the local governments to compete with each other, and maybe they will select some of them. So yeah, I think to answer whether where the foreign strategy would go, it is still very important to research other fields in Chinese technology policy. Yeah, thank you.
Well, yeah, if I may, I want to borrow 3 minutes from FNL. Maybe quickly respond to David's question about, okay, we have policy recommendations for the United States, and whether we have a policy recommendations as well for Taiwan. And yeah, this is a very great question. And why we end up didn't mention this part is still progressing. But if you're witnessing several milestones has been achieved between the U.S. and Taiwan, I think one of the most remarkable milestones we've been achieved is we signed the agreement on reciprocal trade, we call it ART, right, on February 12th this year. So many of the analysts just focusing on the tariff rate, but we believe the more important part of ART might be, we believe this is one of the first documents announcing that from now on that the U.S. and Taiwan has to align its export control regime, including in the article of ART, Taiwan has been requested to reform our export control regime. Also imposing FDPR, foreign direct product rule, and in order to totally align with the U.S. Because again, so I think Taiwan's role in terms of this AI stack is still really pretty focusing on hardware, right? Because not only TSMC, they're supplying maybe 100% the most advanced semiconductor chips. It's already 6th largest company in terms of the market share, and historically TSMC is the largest, right, manufacturing companies of the humanization, human civilization. And also Taiwan has been supplying the world around, last year 82% of the AI servers mostly for the US. So now Taiwan has become the 4th largest trade partners to the US, right? The first one, the second one is like Canada, Mexico, and third is still China. But Taiwan has suddenly become the 4th largest trade partners for keeping supplying the US AI hardware stacks like chips and servers. So aligning with the US regulatory regime is, we hope that we can make sure that Taiwan and US can jointly dominate the AI era. So from now on, there's many works we have to do. We have to reform. We have to figure out how to align with this US regulatory regime, and by reforming our side's part. But on the other hand, in terms of the software, in terms of the model training, we don't have many of the advantage. We believe that only the US and China are the 2 largest stakeholders and players for this model training competition. Taiwan suffers a lot because if you are accessing to the Chinese model, Chinese data, then because we are Mandarin using world, so it's easier to be affected and polluted. Maybe I'm using this term. Those if you are English users, if you are other language user, you might not be directly affected. But whenever we are using model, we are in the AI era, that might be we have direct impact from the Chinese, if they are keeping using AI and keeping training their model and keeping using their data, then that might be huge impacts on us. Okay, so yeah, the last 30 minutes, we're going to have our audiences to ask questions for any of our co-authors or discussants. So please type in that. Let me check the box. Oh, so we haven't yet have a question. So if you want to ask a question, please type in and submit the questions, and I can read the questions for you. Lizzie, okay. Yeah, Lizzie is our colleague. So Lizzie, you raise your hand if you want to ask a question or.
I think only the moderator can open their mic. Yeah, so you have to ask the question under the Q&A. You have to type it in under meeting tools and then Q&A. I think we may be having some technical difficulties.
I'm trying to figure out. Lizzie, can you try again?
Hi,
okay.
yes.
Yeah,
Can you hear
here.
me now?
Yes.
I'm not sure if it's just me or other audience members as well, but we don't seem to have access to the Q&A box. But anyway, I would just like to quickly ask a question. Thank you both for the great report. A little bit about the difference between open weight and open source, and how the Chinese AI elites, you researched how they view the differences between these two as well. Thank you.
Maybe I can start, and then I'd love to hear the other panelists' thoughts on that, and especially maybe the relevance of that distinction. From our perspective, I think well, I guess I'll start by saying that kind of open source technology has kind of long been a kind of Chinese industrial policies, since the kind of personal computing operating system era. However, in this kind of age of generative AI, kind of open source definitions don't necessarily apply neatly in this case, because openness is kind of more of a spectrum in the case of AI models. So there are a lot of different factors that can be disclosed to the public, from training data to kind of the other data provenance, and so most of the models that we look at from China are open weight. That they're able to be downloaded and fine-tuned, but some of the background information is not available. So that's kind of the distinction there. But it still seems that even though they're not fully open source, they're still being rapidly diffused across the global south, as Wendy was talking about. And because they're not open weight, because they're not fully open source, there are things that are not visible and may pose kind of certain security risks or data risks that need to be kind of taken into consideration. That said, it's not just the models that we're talking about that are important, but there are the parallel computing platforms, there are the machine learning frameworks, all of these things that maybe fall more into this traditional definition of open source that China has really tried to dive into, to kind of both prevent both to diffuse their technology, but also to prevent overdependence on the United States. So I'll stop there. I'd love to hear others' comments.
Maybe just to jump in on that, on the other kinds of open source platforms that China is trying to develop. One is, speaking of Huawei's jumping in everywhere, is for the longest time, Huawei is trying to reduce its reliance on Western mobile operating systems, namely Apple's iOS and Google's Android OS, which there is an open source version of Android, but also the more proprietary global Google Mobile Services version. And all of this was kind of kickstarted when, speaking of FDPR, Huawei, the US imposed FDPR on Huawei back in 2017 or 2018. A lot of the emphasis was put on Huawei's access to chips, but I think the less well-covered restriction that Huawei was subject to that perhaps had equal, if not more of an impact, was Huawei's restricted access. Huawei's access to Google Mobile Services was restricted, and that meant that Huawei smartphones, which relied on Android operating system in overseas markets, was no longer supported. So Huawei then set off on trying to develop its own Harmony operating system, which is open source, and created and tried to create and is in the middle of creating an open source ecosystem to try to diffuse it across not just China, but global markets outside of China. So this also has a very much, 4 ounce deflecting 1,000 pounds kind of vibe to it. But again, it's still kind of a nascent development that still hasn't hit the mainstream yet globally. But I'm sure it'll get there eventually.
I think maybe I will also quickly jump in here on this topic. Yeah, I think when maybe go back 2 years ago when we're first starting to look at generative AI, I think we also talked a lot about this distinction between open weight and open source, and how models tend to be open weight rather than open source, and how that at the time seemed like it would be a bigger deal because it means you can't see what kind of training material goes into it, which creates all sorts of questions about, okay, what if it's biased? What if it's, especially pertaining to censorship, maybe in China, or you just don't know what's going in there. But fast forward to today, apparently the market doesn't care that much, right? It seems like the overwhelming maybe cost differential is enough to overcome some of these concerns, at least for now. I mean, I think maybe if you're a US enterprise, you probably would have more qualms, or maybe there will be or should be guidelines on using models that are open weight and you don't know what's in the back of it. But for the most part, it seems to not matter as much as we thought it would. Which is interesting. It's not what I thought 2 years ago. But the other thing I would say on open source is it's one thing that these models are being quickly diffused and adopted to be built on top of. But I think the harder thing for adoption to spread is going back to what we're talking about. It's the actual tools. So the CUDAs, the kind, or the Mindspore, which also came up in the report, right? It's trying to replace these very fundamental building blocks in software. I think that is much harder, just because you really basically have to convince all Chinese developers, or a large majority of them, to use this new tool, and that's a much harder thing to accomplish, I think.
All right, thanks so much, Wendy, David, and Nathaniel. Now I can see 2 questions from my side. I can see firstly Kathy, one of our colleagues as well. Kathy Fan asked this question: what areas of disagreement or divergence exist among Chinese elite actors, despite the broader convergence of views?
Yeah, okay. I think I can respond to this question, and I want to talk about 3 aspects. The first is the attitude toward the question whether China will win in this AI competition in the next few years. And although the the presentation we made today, it seems like most of them are quite optimistic, but I think there are still existing some pessimistic voice in China. Especially, I remember, is it from like the founder Moonshot, or I forgot his name, but like when he was asked in the AGI roundtable that in what percentage, like how many chance do you think that China will exceed US in few years? And he says that even in the most optimistic view, I think only 20%. 20% is already very high, and I think his reason is quite convincing to me, because he talked about the limit in high training compute power, because like in the domestic labs, they already spend most of their computing power to meet their clients' demand, so they wouldn't be able to push more in the model training. And this is kind of like counter to other elites who were very optimistic that China could kind of like circumvent the lack in compute power merely by using AI model training. Yeah, so I think this is one different view, especially like in China. I think everyone wants to hear about like optimistic news. And the second difference is I think it's in the Anthony and I talked about like why people in the same AI stack, they may view a question very differently and give out very different opinion, and it's about like what stream they're actually in. Like for example, in the energy and infrastructure part, if you're asking to like a business stakeholder or a industrial observers, they may be optimistic because they think that China has abundant energy, and there are all kind of like a centrally coordinated project to kind of like channel the data center and the need of power. But however, if you go to ask an energy engineer, then they may give out some very different view. Like they may talk about lacking talent of an energy engineer, and maybe there are. Or if you go to the cloud industry leaders, then they may talk about like, oh, there's some misallocation in the demand for data compute and supply. So it kind of like depends on who you ask. Then they may give out very different views. But and I think the third is that, sorry, I need to kind of look at my notes. Sorry, I forgot what was I was going to talk about. Yeah.
Yeah, it's okay. If you recall, you can follow up. Because okay. Now I can see 3 more questions from the audiences. So the first question asked is really focusing on the talent issue. He asked, well, this audience asked it, with many top AI professionals in the US and rest of the world actually coming from China originally. What is your take on the talent security trade-off? Should we view this primarily as a security threat or as an opportunity to integrate the Chinese top talents into Western AI ecosystem? It's a great question. Anyone want to pick this question?
Maybe I can jump in. I think, yes, I think in the US at least, we should totally have open doors for Chinese engineers to come to the US and stay. I think the trick has always been, and I think there's actually a widespread political support for this idea of, you know, attaching green cards to PhDs in the US. And trying to convince and find ways and vehicles to convince not just Chinese, but just foreign STEM students in the US to stay in the US after they get their degrees and find jobs. And I think there is bipartisan support for that in the US. I think the trouble is that very narrow issue always gets pulled into the broader immigration story here in the US, which becomes much more politicized and much more of a tricky topic to talk about. But I think I just saw yesterday there was there was a Chinese engineer that was recruited by Meta's superintelligence lab. I forgot which Chinese firm he came from, but that's just the latest example of how, at least there's certainly appetite among U.S. AI companies to try to bring in as many top-tier Chinese engineers as possible. And yes, of course, the research security will always be an issue, but I think there's multiple ways to solve that, to address that challenge. In the same way that, commercial companies have non-competes and NDAs and all the rest of it, there's lots of regulatory and policy tools at our disposal to address any research security concerns. So if I can also take the opportunity to kind of add on to the previous question, what kinds of disagreements and divergences exist among Chinese stakeholders from Beijing? I think the most, or one of the more illuminating examples of this was over the debate whether or not China should accept NVIDIA's H200 chips. We saw Beijing sending clear signals that it was opposed, if not at least, on the fence on whether or not to allow NVIDIA to sell H200s. But I think we saw many reports, signals from Chinese industry that they're more than willing to buy H200 chips, in spite of Beijing's disconcertations of wanting domestic industry to buy domestic rather than extend its reliance on U.S. chips. So I think that was a recent high-profile example of that industry-government divergence in China.
Could I add briefly onto David's point? I think that the point on the H200s is very interesting because in our research, there are only a handful of companies that kind of publicize, Chinese AI companies that publicize using Huawei chips in when they train their models. And it seems like most of these Chinese companies are still in one way or another using NVIDIA chips. So for like a Baidu or ByteDance, either using remote compute access in third countries or, chip smuggling, etc. And I know Dset has done research on this subject specifically of kind of data centers in Malaysia and other places that are being accessed by Chinese companies to train their chips, because Huawei's Ascend and kind of CAN ecosystem is still not sufficient to train these models.
All right, I see more questions appeared. All right, so this one is pretty similar to David's question. So David earlier questions like, how does Taiwan play a role in U.S. China AI competition, and what can Taiwan do to contribute? Okay, I just reply a little bit, but if any of our co-authors want to add on some of your points, and then please raise your hand.
No, go ahead, Jeremy.
If you want to respond, Nathaniel, you can.
Oh, okay, sure.
Sure.
Maybe just very briefly.
Sure.
I think one thing that maybe Taiwan can do is within the physical AI space. So today I went to an AI robotics event here in Taipei, and I think there was a lot of activity in Taiwan on the subject of physical AI and kind of how Taiwan can fit in this space and kind of be a partner to the U.S. in kind of building a non-China supply chain, especially in robotics and physical AI. And one advantage that Taiwan has that and this was mentioned in this event that I attended today here, is that Taiwan has a big manufacturing sector. It's exports. Taiwan is an export-driven manufacturing economy, and so a lot of these Taiwanese companies are cooperating with NVIDIA, for example, to collect and sort and categorize data from their factories that can be used to train these simulation environments, these models that NVIDIA is developing, that these U.S. companies are developing. Foxconn's Houston plant that is making NVIDIA servers, they have deployed humanoid robotics at this Houston plant using digital twins, using NVIDIA's software, so Foxconn has this manufacturing capability, NVIDIA has the software, and so I think there are a lot of synergies that Taiwan can play in cooperating with the U.S., especially on this physical AI front.
I would like to add on from my previous research, which is mainly focusing export controls and semiconductor. So I think in our policy recommendation, we also mentioned that we need to keep the export control tight and to remain the scarce in compute power. So this is which I think Taiwan should be more aligned with the US, that Taiwan should be more proactive in conducting export controls, because we all know that Taiwan is a choke point of advanced chips, and also some materials and equipment is also could be kind of like supply from Taiwan. So I think it's really important for Taiwan governments to conduct thorough regulations and also enforcement, and also for Taiwanese firms to kind of like being more cooperative and do their KYC. So this is what I think from the hardware side, what Taiwan can do in this AI competition.
Yeah, I still remember in the inauguration day, we released a report titled "Walking a Tightrope." So we actually, by releasing that report, we proposed the Taiwanese government, our policymakers should, do work in order to align our regulatory regimes with the U.S. And it's ongoing trends here. So I believe we just almost to accomplish another project led by Emory. So we are actually examining the entity list and comparing the entity list between the U.S., Taiwan, Japan, and also comparing this kind of difference of detail of this regulatory frameworks. So we want later, if we are releasing this report, we are going to have in our another event for introducing our research findings. Okay. Well, 2 questions left behind. Okay. Let me check. Okay, so this question is for David and Wendy. Okay. Which of the report's 6 policy recommendations do you think should be the U.S. Taiwan's top priority in the short term?
Let me pull those up real quick just to refresh my memory. 1 second.
Or it can be any policy recommendation. It doesn't necessarily be from our report.
Maybe I'll start since I have it pulled up.
Sure.
But so, of course, on the open source, I think it's important for the U.S. to pay attention. But we already talked about that a bunch. I think really on the 6 areas that you mentioned, maybe competing for the ecosystem is the one where I think the U.S. is maybe paying least attention to right now. So the mechanisms that we talked about, how things are more application focused and diffuse very, very quickly inside China, that's a core competency of China's that I think bears looking at from the U.S. perspective, so it doesn't snooze on the consumer market.
Yeah, I think looking at and we kind of talked about this before, the talent piece I think is still, I think, should be a key priority. For the longest time, the U.S. has been kind of the global center of gravity for not just AI, but just S&T development writ large. And I think we should certainly, in the U.S., strive to maintain that position. And I think this has implications not just for AI, but just for, again, S&T, R&D writ large. think that's incredibly important. And again, from the China perspective, Beijing certainly realizes this as a key weakness within the Chinese AI ecosystem. We've seen Xi Jinping himself say time and time again, acknowledging that China has a weak domestic R&D ecosystem, and this is why we've seen Beijing, prominently position R&D and fundamental research as a key priority in the 15th Five-Year Plan. So all to say, short answer, number 5, I think the talent piece is probably the most important.
Yeah, thanks so much, David and Wendy. Okay, we've already run out of the questions, and it's about the time for wrap up this event. Well, we've been releasing a series of open source intelligence reports on researching the Chinese semiconductor AI ecosystem, supply chain. The deeper we dive into, the more we realize that the Chinese is really seeing this grand competition in totally kind of a different ways, right? Whenever the U.S. want to identify the battlefield, identify maybe the approach we want to compete with them, they are seeing this grand competition in totally different way, right? They want to maybe identify a different battlefield. They want to fight a different war with us. They want to win in the end of the day, but they're having their own strategies based on our different civilizations. It's a totally different ecosystem. So obviously they have a different thought. So maybe for further understanding their strategies, their thoughts, maybe we got to start to practice Tai Chi. Or this is a joke. Well, thank you so much for joining this invitation. My staff just remind me that during the snapshot session, we actually didn't successfully to take the snapshot. So maybe before wrapping up our event, we got to try again. We hope we can be fine. So please again. Look at the camera, and I'll have my staff to take our good photo. Again.
Yeah, sorry for that.
Sure, thank you.
I'm gonna take a screenshot right now. 1, 2, 3. Okay, perfect. Thank you so much.
All right, thank you so much for our co-authors, Nathaniel and Emery, and also really appreciate to the comments and contribution for this report from Debbie and Wendy. Looking forward to having you physically to attend our forums, and maybe looking forward to meet you, directly with you, and whatever where it is in Washington D.C. or in Berlin or in Taipei. And also recommending, we are showing our slide that there is a QR code, so our participants, our audiences can feel free to access to our report through scanning this QR code. And also once again recommending you to access to the website of SSP and Merrick's for reading David's and Wendy's reports and researches on this issue. We always learn a lot from our partners, both from David's team and Wendy's team. So thank you so much again, and we wish you have a great day, and good night and good afternoon. Thanks so much. Bye bye.
好的，只剩我们了。
Okay. Nathaniel. Okay.
Yes.
海毅. So we're moving to the 会议室。
会议室
OK。
那我呢？
对
你也在留在你的现在的。
你先留着。
可能要请在现场拍一张照片，这样就是才艺影档会出现在某个人的电脑或者平板上面，然后 Nathaniel 跟志成站在那个电视主视觉前面，
应该直接
然后我们
把我上次发表会的图片就是去背抠下来。
再麻烦寄钱，感谢。
Wait, what's happening?
Which room are you in right now?
I'm at home.
Jishen's going to take a photo for you guys.
Okay.
I think so. Where are you now?
我在家。
所以今天拿出我们两个人的
啊？你在家？我以为你们在 Dset 的。
好像之前跟 Jeremy 在 Dset， 但我有。
哇。那你们？
我们就是现在要开电视，把你们两个放在电视上面。
哦 ，OK，
对
，OK， 好。
之前你等下拍完，让我确定一下。我可能要先把你们两个定选，上次你们头会比较大。
那还需要这个模糊背景吗？
显示器有说，
那我电脑不知道为什么之前就一直连不上。
Is Danny there?
Yeah, Danny is here.
哦，
还是用志成
Danny is with us.
你好像跑掉了，Dset1还在Dset1。
因为我之前的
那你们可以先试拍一下你们现场是怎样吗？你这样就是季贤，你拍一下，你现在试拍一下。
我拍一下。那我现
在。你现在投影在哪里啊？
进阶。
我现在在会议室2。
会议室2。
因为我现在在准备。
哦，有了 ，Web OS yes。验证码4308。耶！
操他死！那
对。
等下我先。
你们可以先试拍一下，我想看一下你们现在到底是现场到底是长怎样。主要是我怕那个 Nathaniel 跟才艺的脸太小，我听不到。Oh my god!
You're gonna take a screenshot? 你会截图？
没有应该是现场。你们要现场。
How are you gonna take? I thought Danny was gonna take a photo.
等下说要放主视觉。
对，但是因为你们现在2个人都在，我觉得你不如就放 Nathaniel 跟才艺在那个电视上面，然后志成拿着报告书站在旁边，然后季谦你帮这3个人拍张照，而且他们现在背景都是那个主视觉，所以就还好。你没有开麦哦。
那好，那他们就不用了，他们就好这样子，我们站在这里，然后 Danny 可能要正中间吧。没有，我把电视停一下。好，做一个。好。灯光不够。我需要路径了。你当然要啊，你要做。
可是感觉这边是个还要吗？
这个它会，它可以消掉吗
？Shouldn't you turn off your thingy?
你们自己的镜头 ，Jeremy 的镜头关起来。
好，
对对对，我翻起来，
好
这样会比较好吗？
，OK。
这样，对，你先拍一张。
Wait, should we?
我们现在干嘛？
Are we?
Yeah.
What are we doing?
Danny，
2、3，好，对，1、2、3，好，看一下可不可以？
好，我看一下，
然后发到那个，先发到那个。哎，我站出来一点，我站到太
到那边。
哦，
这样子站在这个电视，我把它当成是一个真的，所以我就躲在它后面。
OK， 对，
哎，才艺在，
假装就这2个人都是真的人，就站在这里。
好，你们准备再一次，
才艺不要遮嘴。
1、
你的手，
Okay, sorry. Wait, hold on.
再一次，好。
1、2、3，好，对，1、2、3，好，你再看一下。
好
的。
，OK 吗？
好，我先给那个艾总看一下。
好，你先发到那个 scanner 里面看有没有人不满意自己的照片。
你们传一下照片到群组，我们看一下。
现在在传。
我觉得
好，谢谢。
标准3严格。
当然啊，他们是最专业、最严格的团队啊。传的蛮好。
不错，但是志成你可以用那个像拿证书的方式拿那个报告。
好。拿证书的样子。
就是怎么讲？2只手拿着。
好，恭喜的。
拿啦，
我双下巴。
上下拿。
上下。
你双下巴这个可能只能。
我想问一下，就是那个摄影师取角度问题，还是
你们现在这样可以，然后你们可不可以把这个荧幕弄成全荧幕，但是不会跑出上面的那个 tabs？
好，我们现在
要求很多，没有不行的话也没关系。现在唯一就是
可以啊，
现在目前上可以啊，
可以啊，把它
试试看。
而且把这个可以把它往上再。
它这个没办法，他们的框框。好，
我不知道苹果的可不可以这样全荧幕。
是不是可以把那个参加者消掉？
哎，我把志成先退出。这个
不行啊，不能把他们都退出啊。
不是，是你，
我退出，他们都听不到声音的。
没有，是我现在是用我的
，OK，
所以少一个
人。
好，
之后再把上面那框框。
你们等一下，这个是连谁的电脑？因为你们这个电脑应该是可以选择把没有开镜头的人都移除。
没有，可是这样就把你移除了。
对啊，你会被移除哎。
没有调整，你按调整检视画面。下面3个点点那个地方，挂电话旁边3个点点那里，点下去之后按调整检视画面，然后最下面有隐藏没开启视讯的方格，你看一下这样可不可以？
哦，酷哎！
可以吗？
看一下这样子。
好，
有，太棒了！还有一个聚光灯。
如果再不行的话，就按聚光灯，应该就只会出现你们2个。
这个擦掉，这个。擦掉，这样我先把这个。
好 ，OK 了，好了，我们4个可以并列了。
那个，志成可能要再过来。
好，
你们要拍之前要记得提醒才艺跟Nathaniel。
对啊，他们很彷徨。
2、3，好，来的，1、2、3，好，看一下。
好，翻。
Good。
要那个 Olivia 和
艾总要
各采各
要鉴定。
我们看起来很像在开那种就是股市节目，就是我们看很像是那种报名牌的那个股票分析师，然后那个季谦跟 Jeremy 在主持这个节目，这样。
都是红色啦，可以，没有绿色。
可以啦，这样可以啦，好啦，赞啦。
好了，感谢大家。
好，
我觉得我拍不好看，我再来一次，再来一次。
第二张才艺的脸。
想要带
各位不好意思，自己先说他觉得他这组没有拍很好看，
听不到。
抱歉，
我
再
第一张比较好。好
没，有，
再一次。
因为他是颜值担当，所以我们只好再。
哦，
我现在用好操控好这台电脑。
What?
taking another one or taking another shot.
Taking another photo.
1、2、3，好，再一个1、2、3，哦，
好，
好了，再传。
其实我觉得应该是你要缩下巴问题，那没关系。
我
就是你买这些照那个大头照，我说那摄影师不会跟你说下巴要缩小一点，
只有缩下巴，只有双下巴
季现在外套没有拉好。
啊。
好，没问题，应该可以了。
好了，今天 OK 就 OK 了。
好，我这边，好。
不是啊，那你们刚拍好新的，也要给才艺还有怎样有确认啊？
有，
这样发到群组里面看一下，
你们看一下，你们不用一直撑着那个姿势。
你们看一下放松，看一下群组啊，表情放松，
可以放松。可以吗？
我觉得1跟4都很好啊。
OK.
好，你们投票啊，我都没差。
好，
好，
那我们没问题就。
好，没问题啦，辛苦喽，
耶，
赞哦，
谢
谢，
拜拜，
谢谢大家，
拜
拜拜。
拜拜。
啊，明天见，拜拜。